square. And the next one is dou square by f, dou square of f divided by dou x1 into x1. Similarly, we are going to find the dou square value for all the x1, x2 up to xn. We are finding the matrix that is the Hessian matrix. Next, we are going to see one problem in the Hessian matrix. So this is the problem. So find the Hessian matrix for the function. So here the function is u. So the defined function is minus xu plus 3xz plus 2y minus y square minus 3z square. So we are going to find the Hessian matrix for this function. So we are going to differentiate this function. So first we are going to differentiate the function u with respect to x. So we are going to differentiate this function with respect to x1. So by differentiating minus x cube, I get an answer as minus 3x square, and then x value is 3xz. By differentiating 3xz, we get an answer as 3z. Then the remaining values we don't have a variable that is x, so we are going to, by differentiating the remaining values, we get an answer as 0. So next we are going to differentiate the function with respect to the y. So by differentiating the function u with respect to y, here the 1 with y values which represent in the function as 2y minus y square. So we are going to differentiate these two variables only. By differentiating 2y, I get an answer as 2. Then minus, again we are going to differentiate y square with respect to y. While differentiating y square with respect to y, I get an answer as 2y. So then we are going to differentiate the same function with respect to z. So we are going to search where are the xz variables. So here only we get a variable that is the 3z square. So we are going to differentiate this 3z square with respect to z. So while differentiating, I get an answer as minus 6, so 3x minus 6z. So these are the values which are we are going to differentiate the function u with respect to x, y and z. So next we are going to differentiate second derivative for all these three values. That is, we are going to differentiate the dou u by dou x with respect to x, y, z. Again we are going to differentiate the second function, that is dou u by dou y with respect to x, y, z, and similarly for the last one. So first we are going to differentiate dou u by dou x with respect to x, y, z. So by differentiating this value with respect to x, I get an answer as dou square u by dou x square. So we are going to differentiate this value with respect to x. By differentiating this x alone, I get an answer as minus 6x. So this is the value of dou square u by dou x square, that is the minus 6x. So next we are going to differentiate the same value with respect to y. By differentiating this value with respect to y, that is dou square u by dou x into dou y. So we are going to differentiate this value with respect to y. So here no y values are there, so we get an answer as 0. And next we are going to differentiate this value with respect to z. So here I get an answer that is z here only present. So we are going to differentiate this value alone. So while differentiating 3z, I get an answer as 3. So next we are going to differentiate the second value, that is dou u by dou y. We are going to differentiate this value with respect to x, y and z. So first we are going to differentiate with respect to y, then I get an answer as dou square u by dou x into dou y. Here no x values are present. While differentiating with respect to x, I get an answer as 0. So next we are going to differentiate the same value with respect to y. So while differentiating, I get an answer as dou square u by dou y square. Here the y value is present, that is minus 2y. While differentiating minus 2y, I get an answer as minus 2. So next we are going to differentiate the same value with respect to z. Here no z values are present. While differentiating with respect to y, I get an answer as 0. So next we are going to choose the third function, that is dou u by dou z. Again we are going to differentiate with respect to x, y and z. So first we are going to differentiate with respect to x. So here this one we get an answer as x. So while differentiating 3x, I get an answer as 3. So next we are going to differentiate the same function with respect to y. Here no y values are present. While differentiating this function with respect to y, I get an answer as 0. So at last we are going to differentiate the same function with respect to z. So here z value is present. While differentiating minus 6z, I get an answer as minus 6. So these are the differentiative value, that is the double derivative which we acquire from the first derivative of the function. Next we are going to substitute these all values in the Hessian matrix. So this is the definition for the Hessian matrix. So here we found all those values, that is dou square by dou u square, dou square u by dou x into dou y. All the values for the Hessian matrix we found in the problem. Now we are going to substitute that all values in the formula. While substituting all the formula, I get the Hessian matrix for the function, that is h of u. The matrix is minus 6 and 0, 3. And the second row is 0, minus 2, 0. And the third row is 3, 0 and minus 6. While seeing this all those problems, we get the same answer for these two. Here also dou square u by dou x into dou u, and here also dou square u by dou y into dou. This is the symmetric value. While differentiating x and y, also here also x and y, I get an answer as 0. So while differentiating x and z, I get an answer as same values, that is 3 and b. So this value we call as a symmetric values. By substituting all those values in the given definition, that is the formula, we obtain a Hessian matrix. That is the final answer. Thank you.